All right, let's dive right in. Data management is an absolutely fundamental pillar of modern surveying and construction. In an industry that's increasingly driven by digital metrics, understanding exactly how we handle information isn't just some back-office IT issue anymore, it's a core professional requirement. So in this explainer, we're going to break down how we transform raw facts into secure, highly actionable project assets for the RICS Level 1 competency.
Here's a quick look at our roadmap for this session. We're going to cover the foundations of data, sources and collection, the data lifecycle, storage systems and BIM, quality and security, and then we'll wrap it all up with an essential revision recap. Section 1, Foundations of Data Management. Let's get the absolute basics down first.
Okay, so here's our first really big concept, the actual difference between data and information. People use these two words interchangeably all the time, right? But in our professional practice, they are completely distinct. Data consists of raw facts. These are your preliminary, unprocessed inputs for any decision-making process. Think of the raw pricing data sitting inside a tender bill of quantities. That's just data. But when we classify, analyze, and organize those raw facts, they transform into information. So taking those raw tender figures and analyzing them to create a comprehensive tender return analysis to advise your client, that is the process of turning raw data into incredibly valuable, actionable information.
Now, according to our sources, data management is the deliberate, structured process where data is collected, validated, stored, protected, and processed. But why do we actually do all this? Well, the ultimate goal is to make sure that the data remains accessible, reliable, and timely for the specific users who need it. It's not just about hoarding thousands of digital files on a server, it's about actively classifying, validating, and managing a true project asset.
Moving on to Section 2, Data Sources and Collection. Basically, where does all this stuff actually come from?
You might be wondering, why go through all the time and effort to collect this much data in construction and project management? Well, there are 4 core reasons. First, simply to obtain vital information about the project or the wider market. Second, to keep highly accurate historical and real-time records. Third, and honestly this is perhaps the most important one, to enable informed decision-making. And finally, to pass that crucial information seamlessly along to other stakeholders, like your clients, contractors, or design teams.
Now, the RCIS Pathway Guide puts a huge emphasis on knowing exactly where your data is coming from. We generally split this into internal and external sources. Internal sources are, as you'd expect, generated right within your employer's organization. We're talking about in-house historic cost data, existing project records, internal budgets, and variation reports. External sources, on the other hand, are published completely outside your firm. A prime example that RICS specifically highlights is the BCIS, the Building Cost Information Service. Other external sources could be published pricing books or broader market benchmarking data. As a professional, you absolutely need to know how to extract and utilize data from both of these worlds. This might involve specific collection methods, ranging from automated digital scraping of market metrics to manual on-site field data collection, or even structured interviews with stakeholders.
Let's look at Section 3, the data management lifecycle. This is the journey from the moment data is created to the moment it's archived. The entire lifespan of project data is broken down into 6 chronological stages. Stage 1 is creation, capture, or collection, gathering up those raw inputs we talked about earlier. Stage 2 is organization and storage, actually putting it into a logical filing system or a database. Stage 3 is where the real magic happens, where the value is realized, using and analyzing the data. Stage 4 involves sharing it with the relevant stakeholders who need it to do their jobs. Stage 5 is maintenance and reuse, which means keeping the data updated and relevant for future benchmarking. And finally, Stage 6, archiving it for long-term legal compliance, or securely destroying it when it's literally no longer needed. Understanding this exact life cycle is absolutely critical for Level 1 competency.
Section 4, Storage Systems and BIM. This is all about the actual digital infrastructure of our data.
Today, project information is stored across a massive variety of electronic systems. At the most basic level, your employer probably uses shared hard drives or local backup servers. But increasingly, the whole industry is shifting to online cloud storage, like OneDrive or BIM 360. For complex multi-million-dollar projects, we use dedicated project management information systems, or PMIS, like Aconex, as well as enterprise resource planning, or ERP systems like SAP. The RICS guide also heavily stresses the importance of understanding centralized databases and knowing exactly how technical libraries and archives are set up so you can efficiently retrieve vital information.
While a project intranet securely hosts data internally just for your own organization's employees, you also really need to understand project extranets. An extranet is a secure computer network that allows authorized external parties, think subconsultants, contractors, or vendors, to view and collaborate on project files. The key advantages here? Massive improvements in communication, way better efficiency, and the fact that it provides 24-hour access from anywhere. And because it's a highly secure environment, specific access and permission settings can be meticulously tailored to each individual user.
All of these systems we've talked about can ultimately feed into the big one, the Centralized Database of Building Information Modeling, or BIM. Now remember, BIM is absolutely not just 3D drawing. For our purposes in data management, it acts as a highly structured information source and a computerized central project database. While BIM offers incredible, game-changing benefits for collaborative efficiency and data integration, the RICS guide explicitly points out that you also have to understand its challenges and dangers. If a BIM model is poorly set up, or if the data being input is inconsistent, the integrity of the entire centralized database is compromised.
Section 5. Quality, Security, and Legislation. How we legally govern and actually protect these assets. Maintaining data quality is essential. High-quality data principles basically dictate that data must be treated as a valuable asset, just like a piece of equipment or cash in the bank. It should be easily shared and accessible to those who need it, but crucially, it must not be duplicated. Duplication causes absolute version control nightmares. Above all else, to be successfully analyzed, data must be accurate, reliable, perfectly consistent, and strictly fit for its intended purpose. To protect this high-quality asset, robust security measures aren't just nice to have, they're mandatory. On a technical level, this means setting up strict access control and permissions, utilizing strong passwords, firewalls, encryption, and antivirus software. You should also be relying on automatic, regular backups, ideally stored in at least 2 entirely separate locations, like a head office server and a site office drive. On a contractual level, if you're a client issuing sensitive project data to external vendors, you ensure security by executing a non-disclosure agreement, or NDA. This legally prevents them from any unauthorized sharing. When you're dealing with data protection legislation, you have to understand the key legal terminology. Let's look at the distinction between a data controller and a data processor, using UK data law as our baseline example here. The data controller is the entity that determines the purposes and the means of processing personal data. Put simply, they're the ones calling the shots. The data processor, however, is the entity that actually processes that personal data on behalf of the controller. Knowing exactly who holds which responsibility is completely vital for legal compliance.
And speaking of compliance, the legislation governing data storage, sharing, and confidentiality varies significantly depending on your specific jurisdiction. Whether you're operating under the Saudi Data and Privacy Law, UK Data Law, or Egypt's e-transactions and cybercrime laws, the core underlying principles remain the exact same. You must safeguard personal and sensitive project data. This legislation also dictates how long you have to keep data. For instance, depending on the jurisdiction and the specific contract type, you might be required to retain project documents for 6 years for a standard contract, 12 years if it's signed as a deed, or even up to 15 years to cover the limitation period for most legal claims.
Section 6. Essential Revision Recap. Let's run through a quick checklist of everything we've covered.
First, remember the true meaning of data management. It is the rigorous, deliberate process of collecting, storing, and processing data so it remains perfectly accessible and reliable. Keep that 6-stage life cycle in your mind, from creation all the way down to archiving or destruction. You've got to be able to cite key sources, distinguishing between internal in-house cost data and those vital external sources like the BCIS and published pricing books. And make sure you understand the basic concepts of how electronic database systems, cloud storage, and shared folders actually operate day to day.
Second, prioritize data protection. Know your firewalls, your automated backups, and exactly how and why to use NDAs. Understand the highly structured role of building information modeling, not just its amazing collaborative benefits, but the very real dangers of mismanaging that central database. And finally, master the essential terminology, particularly the legal difference between a data controller and a data processor.
So to wrap up this explainer, remember that data management isn't just about filing things away. It's about actively protecting the lifeblood of your projects. As the construction industry becomes fully digitized and we rely entirely on these complex databases and BIM models, it begs a pretty huge question. What happens to our critical project data if the specific systems and software that house it become completely obsolete tomorrow? Just how resilient is your data management strategy? It's definitely something to think about.